let's look at arctangent. Find a power series representation of the function arctangent of x. So look at that function. I can't write it as 1 over 1 minus something. So I gotta use derivatives or integrals to help me out. Which one do you want to do? Do you want to take the derivative of that? Or do you want to integrate? Do you remember the derivative of that? 1 over 1 plus x squared. So let's take the derivative. F prime of x, 1 over 1 plus x squared. Again, I get 1 over 1. It's good. But I have this plus, so we just do what we did on the last problem, change it into a minus. And from here, I can write a power series for this using my formula. So I'm going to plug in, again, this thing in parentheses here is what I plug into my formula. N equals 0 to infinity, negative x squared to the n. So this is, if you want to simplify it, negative 1 to the n, x to the 2n. So we found the power series for f prime of x, but that wasn't my goal. My goal was to find it for f of x. So I just need to integrate to get back to my function f. Okay, so we're going to get arctangent of x, what we do is we integrate. We're going to integrate 1 over 1 plus x squared, which I'm now replacing with its power series. Let's see, if I plug in 0, it's positive 1 minus x squared plus x to the 4th minus x to the 6th. And then you just integrate term by term. So I'm getting c plus x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. So it looks like c plus the sum. If you want to know how to come up with this formula, go back to your original formula up here. And you're going to add 1 to the x and divide by that, the power of x, and divide by that number. So I'm going to get x to the 2n plus 1. Over 2n plus 1.
So to get those values that you got in that second integral, did you plug it into the arctangent equation, the original f of x?
What I did is I said I plugged in values into here.
Okay.
Because it's a lot easier if you write out these, because then you're integrating things. It might be confusing if you just plug in this thing right there with the integral and the sum. And so for some people it helps you to write out the terms here. So I plugged in n equals 0, and you're going to get 1.
Okay.
N equals 1, you'll get negative x squared. N equals 2, positive x to the 4th. Okay. Okay, so we've almost got our power series for arctangent. All I need to do is find this value of c. So I need to plug in something for x. What should I plug in? let's think about. I want all of these terms to go away, right? On the right-hand side in this series. So you're gonna plug in 0. You wanna plug in whatever this power series is centered at. This is a power series centered at 0, because it's just x. It's not x minus 2 or something like that. So I'm gonna plug in 0 to solve for my c value. Okay, so let's do that. I'm gonna have arctangent of 0 equals c plus, and again, when you plug in 0 on this right-hand side, I'm going to write it here for you so you have it. But all of these terms on the right-hand side here, other than c, are going to be 0. So you're just going to get arctangent of 0 equals c. Now we got to remember what arctangent of 0 is. Tangent of what angle gives me 0? Tangent is sine over cosine. So where is sine 0? At 0. At pi over 2. Yeah, at 0, right? It's a little bit hard to think of these inverse trig functions because you have to think of what angle gives you what number in the parentheses. So the angle of 0 gives me tangent is 0. So in this case too, it happened that c was also 0, and it just really depends on your function. But now we can write down the power series representation for tangent of x. It's -1 to the n, x to the 2n plus 1 over 2n plus 1. That's my power series representation. Okay. So this opens up kind of a whole new world for us of functions. We weren't able to represent with power series before, but now we can.